All right, this is part 2 of chapter, section 4.1. Going back to the top of page 2 of your notes, what is the probability that a randomly drawn card from a deck of cards is a king? Now remember, you have 4 kings, right? One for each of these. And so 4 out of 52 turns out to be 1 over 13. Okay, no problem here, right? How about a spade? Well, you have 13 spades out of 52, and that's 1/4. And now you can also say, well, because there are equal number of cards in every suit, and you have a 4 suits here, so you have 1 over 4. That's the same argument. The queen of clubs. How many queen of clubs are there in this deck of cards? Basically 1. All right, so this is 1 out of 52. This, by the way, this is an outcome. Okay, the others are combinations of outcomes, but this one specifically happens to be an event that is also an outcome. And then how about 7, 8, or 9? The word or means 7 is okay, 8 is okay, and 9 is okay, right? You have 4 of these, 4 of these, and 4 of these. And so you have 12 out of 52. Let's go ahead and write that down. My letters, characters look kind of funny here. 12 out of 52. And that happens to be 4 out of 13. Okay, actually, this is 3 out of 13. All right, so that's how you can, do this. And you can see that the counting process is pretty significant when you solve probability questions. All right, the next point. 2 events, and this is an important word here. 2 events are called, an important word, independent. I have used this word before, the third coin toss or coin flip is independent of the first 2. It means that the probability is not influenced by other things. Okay, so 2 events are independent if they do not mess with each other, if they do not influence each other in any other way or in any way whatsoever. All right, so here's an example. If you flip 2 coins, okay, the outcome of coin 1 is not going to influence the outcome of coin 2 or vice versa in any way, right? If you draw a card and then if you roll a die, okay, do they influence each other? And the answer is no. So these are independent events. When events are independent, okay, there's an easy and convenient way to calculate the probability. If 2 events are independent, then you multiply the probabilities of these 2 independent events, and that would be the probability of those 2 events occurring together, right? So let's try to find the probability that you get a tails on the flip of a coin and draw a queen when you draw a card. All right, so you see what's happening here? You toss a coin and you draw a card from the standard deck of cards. What is the probability that you get a tails and you get a queen? Well, the probability of getting a tails is 1/2. And the probability that you get a queen is, remember, this was 1/4, right? Because it's, well, you can say it's 4 out of, oh, no, that's not queen. All right, the probability of getting a queen is 4 out of 52. That's 1 out of 13. All right, so the answer is 1 out of 26. You just multiply the 2 fractions and you get that. So that's not hard if you happen to know that 2 events are independent of each other. Events with an and, okay, so it's an intersection. Events with an or, it's a conjunction. You kind of have to be careful with that. And that's something that we will be talking about later. Okay, so not to worry about this at this point. All right, now in applications, okay, in real applications, the probabilities are often expressed as percentages. So let's go ahead and sometimes it's in a common day language, we want to use percentages. we use percentages often in real life. And here's a situation. And I mean, this is the kind of thing that people, study when they suspect like social injustice or discrimination or equity gap or, disproportionate impact and so on. All right, so let's take a look at this. This is fictitious chart. DMV, the Department of Motor Vehicles driving test results for a particular month. And you have men taking the test, women taking the test, some of them pass, some of them don't. And here are the total. We have 200 people taking, and by the way, just take a look at all of these numbers and try to state what you can read off of these numbers. All right. So for instance, you can say, how many men took this test? Yeah, it's 90, right? Because you can see that here. How many women? 110, total is 200. And you have 80 successful drivers and 120 who did not pass the test. And you have disaggregated data between men and women and so on, right? So 200 people took the test. What is the probability of S? S stands for success. That's the name of the event, S. The name of the event F is F for failed. And then you have men and women, M and W respectively. So what is the probability of S, the person succeeding? What you have to do, and you'll have plenty of problems like this on your homework, okay? What is the probability of success? Instead of looking at these two numbers, you have to look at this number. 80 people succeeded out of 200. Okay, now you can say it's 80 over 200, or you can say it's 0.4, right? But many times, if you're reporting this in the news or in a report, you'll say 40%, right? 40% of 40% of the all the people who took the driving test passed the test. Okay, how about the probability of W? That is the probability that the driver who took this test was a woman. Again, instead of looking at these numbers, you look at the total number. That's 110 out of 200. And that turns out to be 55%. 0.55, which is 55%. Okay, so that's how you read this kind of chart. This is sometimes called a two-way table because you have columns and rows. Basically, it's a matrix of numbers. All right, now, remember what I said about events with an and or? These are a little confusing. You have to count them carefully. So what is the probability that S or W occurred? What in the world does that mean? Well, this is the probability that either the driver passed or the driver was a woman. What are we talking about? All right, so you count all the female drivers, that's a W, and all the ones who succeeded. So let's go ahead and use a different color here. I'm going to use maybe green here. Probability of an S. The S columns, that's all of these people. Okay, and the women. Women are all of these people. Okay, notice here, when you count S and W, you're actually including these people who are women who successfully pass the driver's test twice. Okay, so you can't count these 45 people twice. And so what you have to do is making sure that you count them only once, right? Let me go ahead and write it this way. The probability, the number of S, number of people in the S column is 80, okay? So 80 people passed. And the number of women was 110. So if you add S and W, that's 190, right? So let me just go ahead. I don't want to write S. S is the name of the event, right? So I'm going to put number of people in S, number of people in W. If you add these two numbers, you get 190. That's not the number of people that we are interested in. So what you have to do is to subtract these people that we counted twice, right? So the number in S intersection W, this is the number of people who belong to W and S, the number of people who are women and the ones who passed. That's 45. So what we have to do is to add up these and then subtract 45, right? So the number of people in S or W is 80 plus 110 minus 45. So that's 190 minus 45. That's 145. Okay, so we have 145 people that were that either passed the test or were women. And so now we have 145 divided by 200. This turns out to be 72.5%. Okay, so that's how you can calculate the probability of A or B. Okay, when you have two events and that are connected by the word or. Now, if you have the word and between those, okay, then what you have to do is just look at how many people satisfy this condition, S and W. So that means successful and women. And of course, this, I mean, it's very clear from the table. It's 45, right? So this will be 45 divided by 200. And this turns out to be 0.225 or 22.5%. Okay, so the probability of S and W would be written this way. And so that's pretty simple. But the or is the more of a difficult part. Okay, now are these two events, S and W, independent? So S is the probability that somebody, that the driver passed the test. W is the probability or the event that the driver was a woman. Okay, are they independent? Well, look, if you know what the probability of S was, that's 0.4, right? What was the probability of W? Do we have the probability of W? Yeah, we do have it. Probability of W is 0.55. These are the numbers we calculated here. If you multiply the probability of S and the probability of W, you can do this on your calculator, of course, right? What you will get is this is 0.22, right? So it's 22%, right? Whereas the probability of S and W turns out to be 22.5%, right? It's slightly higher, not very much, but slightly higher. And so what this means, this is critical. Now, what this means is, see, the thing is, if S and W were independent, remember what we said about independent events? You could multiply the probabilities to get the probability of an and statement. And so the fact that this number, which is 22.5%, and the product of these two probabilities being 22%, the fact that these two numbers are different indicates to us that these are not completely independent. Okay, so let me summarize what I just said here in words. If S and W, these two events, you know, successful and women, were independent, these probabilities, you know, the ones we calculated, the 22.5% and 22%, maybe I should say that 22.5% and 22% would be equal, but they're not, okay? Therefore, S and W are not independent, okay? In other words, the success rate, maybe I should say that, the success rate depends on whether one is a man or a woman. Now, in this case, the difference is very, very small. So you could probably say that there's no bias or there's no discrimination happening, because I mean, 22.5% and 22% are very close to each other. And there is probably not enough case to argue that you know, one gender is preferred to the other. happens to be probably just a natural variation. But if the numbers are very different, then you can bring the case saying, hey, there's something going on. All right. So whether something is independent or not turns out to be a pretty important factor in application in like, social justice, sociology, and so on. All right. I think you are ready to answer these questions in the quiz for section 4.1. Make sure you do your work on your printed copy and then go on to the online quiz for section 4.1. All right, next time we will do 4.2. So have a wonderful day and I will talk to you later.